Hi everyone! In this tutorial, you'll learn how to build a clone of the classic Nintendo game Duck Hunt. Our version will be called Duck Hunter. We'll be using the TypeScript programming language and the KAPLAY game library. In our game, the goal is to shoot ducks using a cursor that's controlled with your mouse, compared to the original game, which was controlled by a gun-like accessory. By the way, you can buy that kind of a gun-like accessory that you can use as a mouse, so maybe you would want to use that for this game. But no worries, it's not mandatory. But if you want to get a closer experience to the original Duck Hunt. So each time a duck is shot, you earn 100 points. There are 10 ducks to shoot every round, meaning that you have 10 tries and 3 bullets on each try. If you successfully shoot all 10 of them, you gain an additional 500 points. Every round, the ducks move faster, making the game more challenging. You can play the game in your browser using the link in the description. Now let's look at the prerequisites for following this tutorial. This tutorial assumes that you are already familiar with modern web development. That means you should know HTML and CSS and of course JavaScript or TypeScript. So in the case if you're coming from JavaScript, so you only know JavaScript, you should be able to follow this tutorial without much trouble because the TypeScript we will write is very simple. It is as close as possible as vanilla JavaScript. So it's just JavaScript with types. You should also know how to use Node.js and NPM, how to use Git, and how to use a terminal, and of course, how to use an editor like VS Code. However, knowledge of the KAPLAY library is not assumed. The goal is to teach you the relevant KAPLAY concepts as we go through the project. So you might be wondering what is KAPLAY in more details. To put it simply, KAPLAY is an open source library for making games in JavaScript and TypeScript. Compared to the more popular Phaser game framework, its API is a lot simpler, making it easier for beginners to pick up. So by API, I mean how you actually use it, which functions you call, etc. It's relatively easier to pick up than Phaser. It also offers a lot of pre-made functionality out of the box. So that means you spend, therefore, less time reinventing the wheel. For those familiar with the Godot game engine, you might be accustomed to the concept of nodes, which acts as building blocks containing out-of-the-box functionality. So KAPLAY has a somewhat similar concept to nodes called components. If you want to learn more about KAPLAY directly from the source, you could check the KAPLAY docs, which I will link also in the description. So now let's get started. Alright, so to set up a project, first create a folder. That folder can have whatever name you would want to have, and then open it up in VS Code. Once you do so, use the integrated terminal and run the command npm create vite at latest dot. Once you do this and hit enter, you'll be presented with a select a framework options. Select the vanilla option. Once you do so, because we aren't interested in using any framework, front-end framework for this project, since we're using a specific library for making games. So pick the vanilla option. Once the vanilla option is selected, you're going to be asked again to choose a variant, so between TypeScript and JavaScript. Since this tutorial is using TypeScript, select the TypeScript variant. Now, after pressing enter, you'll see a bunch of files being created in your directory. You'll see a public folder, a source folder, a .gitignore, an index.html file, a package.json, and a tsconfig.json. I assume that you have familiarity with modern web development, so I will not go through each of them. So let's get rolling. So now let's install the KAPLAY library using npm. So to do so, we will use npm install command in the terminal the name of the library, so KAPLAY, and then the specific version. So the version I want you to use, so by default you would just write npm install KAPLAY and then use that as the command for a new project. But let's say you're following a tutorial like you're doing right now. You want to install a specific version so that even in the future, if you watch this tutorial far into the future, whatever I teach in this tutorial will work. So to do so, we were going to use in this tutorial version 3001.0.19, which is the version of KAPLAY I want you to install. To install it, you use the command npm install KAPLAY and then type in the name of the version, which is 3001.0.19. Now you might be wondering, like, this is strange. Why are there 3,000 different versions and more? Well, KAPLAY, the way it works, its versioning system is a bit unconventional. That means version 2 of KAPLAY is version 2000, and it was when the library was called Kaboom. It was Kaboom 2000, then it got a rebrand and was forked and made continued under that new name. So version 3001 could be viewed as the version 3 of KAPLAY, and it's therefore less daunting than hearing version 3001. Anyway, let's continue. So once you have the libraries installed, I want you to use the link in the description. So I'm going to leave a link in the description with the assets we need for this game, for this project, and place all of these assets under the public folder. So you should have 3 folders within, one called fonts, one called graphics, and one called sounds. And in each of them, you should have, for example, on the fonts one, you should have a Nintendo-NES folder, and within you should have a NES font, which stands for the Nintendo Entertainment System, which was the original game console on which the Duck Hunt game was released on. Then for the graphics folder, you should have a background.png file, a cursor.png file, a dog.png, a duck.png, a menu.png, and a text-box.png. Finally, for the sounds, you should have a bunch of them. I'm not going to list them all, but using the link in the description, you can get everything that you need. Now for the source folder, I want you to actually remove whatever is in that folder. We're going to just write everything from scratch. So the source folder, src folder, is where we're going to write our code. So here, I want you to create 2 files, main.ts and KAPLAY ctx.ts with a capital C. So the first file stands for KAPLAY context, and it's where we're going to initialize our KAPLAY library by creating a context that we're going to use in our project, everywhere else in our project, to call various functions related to KAPLAY. So the way you do this is first you import KAPLAY from KAPLAY using this import statement, and then create a constant called k and call the KAPLAY function, which allows us to create a context for the KAPLAY library, which essentially means that we're going to initialize our canvas and have now access to all the various functions that KAPLAY offers that we can use. Now, this could be enough, but we want to specify a few options like the width and the height of the canvas, etc. And for that, you can pass an object to the KAPLAY function and specify a bunch of properties. So the properties we're going to specify are the following. So first of all, we're going to set a width of 256 and a height of 224, which corresponds to the original resolution of the NES Entertainment System. So actually NES stands for Nintendo Entertainment System. Anyway, so this is going to be the resolution of our game. And then you're going to set the letterbox property to true. This will make sure that the game canvas will scale regardless of the screen size. That means that even if you're playing on a big monitor, it's going to just scale up the canvas so that everything is nicely visible. We're also going to set the touch to mouse property to being true, so that the game will be playable on mobile if someone wants to use their mobile phone to play this game instead of a mouse on a PC. I'm going to scale, using the scale property, the game 4 times so that it looks nicer. We're going to set the pixel density property to be the same as the device pixel ratio. The reason we're doing this is that if you were to not have this option, you're going to realize that on certain screens, for example, on my 4K monitor, the game looks a bit blurry. So by doing this, by setting up the pixel density to be the same as the one from your device, by calling the device pixel ratio, which is, by the way, a variable that is globally available in the browser. So that's why you can just call it here, even though it's defined nowhere in our script, in our file. That's why you can use it. So by using that, we're able to set the correct pixel density so that our game will look sharp in any screen. We also set the debug property to being true. Now, debug mode is a mode offered by KAPLAY that you can access by pressing the F1 plus the Fn plus F1 key on Mac, or the F1 key on Windows. And you need to do that within the web page in which the game is running, so that it will open a debug mode in which you can see all the hitboxes and debug information and the FPS count, etc. that are very useful information when developing your game. So here, by default, when you just create a KAPLAY game, this debug mode is enabled by default. But just so that I always explicitly put the property here as true, so that when I actually deploy the game in production, I can remember to set it to false, so that in the final build, when the build that is accessible by players, they will not be able to access the debug mode. Finally, we set the background to being an array of 3 values, which corresponds to the RGB color channels, which varies from 0 to 255 for each of them, and is used to define color. And here I want the background of our web page to be black, so the game will be fully black. Finally, we export the constant by using export default case, so that we can import it in our main.ts and anywhere else we need to call KAPLAY functions. Now, one thing I forgot to put here is the global property. So you should be careful with that. You should have a global property set to false, so that KAPLAY functions can only be called by using the k constant, so k dot the name of the function. Here I forgot to do this, so please add it. So that way it's going to keep everything nicely organized, and you won't risk. I would assume if, for example, you're collaborating with others, it might happen that I don't know, they call the KAPLAY functions directly and it's going to produce a mess. So when you set the global to false, every KAPLAY function can only be called by using the k constant. So that's something that is really handy. So after having exported the constant, let's go to main.ts and let's import it here. So import k from the KAPLAY context file. And then here we're going to define our scenes. So scenes in KAPLAY can be set using the scene function. So that's why we can do k.scene, and it takes 2 params. The first one is the name you want to use for that scene, and the second param is the function that will run when the game enters that scene. So for now, let's have a main menu scene with an empty function. Let's have a game scene with also an empty function that we'll fill later, and a game over scene. So those are the 3 scenes that are going to be useful for our game. The names main-menu, game, and game-over are arbitrary names. You can pick whatever name you want. However, I would assume that if you're following this tutorial, of course, choose the same names as me so that you will not get confused later. Finally, we need to set the default scene. The way we do this in our main.ts file is to call the go function, so the go KAPLAY function. This function is not only used to set the default scene here, in our case, but also used more generally when you want to go to another scene. So if I were to call this k.go function within a scene, the scene function, then it will be used to go to another scene, etc. So here we call k.go to go to the main menu when the game runs, since main.ts is the entry point of our project. And it has been set up that way by Vite, if you look at the index.html file. So now let's run the project, run the command npm run dev. Once you do this, an address will show up in your terminal. Click on that, and you should be able to see your game, a web page containing your game. For now, let's go back to the KAPLAY ctx.ts file and let's comment out the background property, just so that you can see that by default, KAPLAY will create a checkered board for the canvas. So that's something just I wanted to show you so that you can differentiate between what is the canvas area and what is just the background of the page. So now let's work on the main menu scene. So first, let's import the menu asset. So basically, an image that said Duck Hunter. And to import or to load assets, you can use, especially images, you can use the KAPLAY load sprite function. The way it works is that it takes as the first param the name you want to use for the sprite you want to import. So in our case, it's an image, which is the Duck Hunter screen. And here we decided to use the menu as the name. And the second param of the load sprite function is the path where to get that image. One thing to note is that when using a module, a build tool like Vite, you can specify the path as if it were from the root. Despite the fact that our images are within a public folder, Vite will make sure that whatever is in the public folder can be accessed as if it were from the root of our project. That's why I don't need to specify public/graphics/menu.png, and I can just immediately do graphics/menu.png. Now to display a sprite, you need to create first a game object and then use the sprite component on it. So a game object is something very important in KAPLAY. It's one of the core concepts. The way you create a game object is by using the add function, KAPLAY function. A game object is composed of components, and KAPLAY offers a bunch of components, and those components add functionalities and features to your game objects. So for example, the add function we're going to use here to create our first game object is going to be, it takes in an array as the param and an array of components. So the first component we're going to use here is the sprite component offered by KAPLAY. You can access that by calling k.sprite. And then here, since we have loaded our sprite asset, we can use, since we have loaded our menu, we can use the key we used it for that sprite and use it in the sprite component. So here I can do sprite and then pass in the string menu, and it will display the sprite, the menu image as the sprite of that particular game object we're creating. Now, if you look at the result, you can see that we have a nice looking Duck Hunter title screen. So now let's go back, and by the way, if you press the F1 key or the Fn plus F1 key, you can enter the debug mode, and here you can see at the top left corner an FPS counter telling you the frame rate of your game. Alright, so now we're going to create another game object, and this game object is just going to contain a message, a text to say, like click to start, a message that tells the player to click to start the game. The way we're going to do this is, of course, again, create a game object, and within the game object, use the text component, which is another component you can use. And here, the text component takes as the first param a string, which is the text you want to use, and as the second param, optionally, the font options, the text options to be more precise, where you can specify the font and the size of the font, etc. So here we're writing click to start, and then we're going to, in the font, the text options, we're going to specify the font as being the NES font with a size of 8. Now NES, the string you see here is not defined anywhere, so we need to first load our font. So here I'm going to use k.loadFont, which is again a function created by KAPLAY. From KAPLAY, and it takes as the first param the name you want to use for that font, and then the second param the path. So here again, in much the same way as with the load sprite, we use here the NES name, so that's why we used the NES name earlier on. And now this should actually display some text with a click to start. We're using the font we specified. Now, before we go and look at the results, let's first set the Z layer. So again, we can do that by using another component offered by KAPLAY, The Z component allows you to specify the layer on which the game object will be displayed. This is very useful when you want to display objects on top of others. And here we want the text to be on top of this menu sprite so that it is not hidden by it. So by default, I think you could, by default, it's in the rendering is in order of creation of the game object. So because we first had the menu sprite created, the game object with the menu title screen, then if you were to use the create the game object with the text, it should normally not, you shouldn't need to specify the Z layer, but I don't remember actually if there were an issue here. So here in the code, I wrote it as I set the layer to being 2 so that I'm sure that it is on top of the title screen. Yeah, by the way, I removed it just right after, so yeah, it's not needed in the end. But however, we're going to use the anchor component instead. So the way the anchor component works is that it is used to center the game object. By default, game objects are rendered from the top left, from their top left corner. And sometimes you don't want that. You want to render a game object from its center. And the anchor component allows you to specify that. So that instead of rendering game objects from the top left corner, which is something that is, things are usually rendered from the top left corner in various graphics programming environments. So not necessarily just here with KAPLAY, but if you use any graphics library, or for example, I think P5.js or any other library, usually things are rendered from their top left corner. Now, using the position component, pause, we can set the where to place the game object on the screen. Here, as the name implies, as the name of the component implies, a position is in a 2D space is an X and a Y coordinate. So here I'm just gonna use this center. So KAPLAY offers the center function, which allows you to get the coordinate of the center of the canvas. So by calling k.center, and then the function, you will get a vector 2, which contains the X and Y coordinate. So here I'm using the X coordinate for the X, the X position, and I'm using the Y coordinate of the center plus 40 for the Y position of the text of the game object containing the text. Click to start, so that it appears a bit below the sprite duck hunter, between the image duck hunter. Now we're going to do again another game object, just for crediting, I guess. I wrote made by JS Legend, and then here again the font size, etc., and then the components for the position, etc. Here again the Z layer is not necessary, and one component I want to cover is the color component, which you can use to specify some colors. And that's a good opportunity to create a constants.ts file, and here we're going to create a constant called colors, which is going to be a JavaScript object, and in that we're going to specify the blue color we're going to use for our game. And as we go along in this project, I will add a bunch of other colors to it. So here you can just call it, make sure to import it at the top of the main.ts file, and now we can use colors.blue, and it's going to display this text in blue. And finally, just to not make the text too obvious, I guess, we can specify the opacity of our text of our game object, not just the text, of using the opacity component and setting it up to half, so 0.5, because the opacity component takes a value between 0 and 1. Now, if you look at the browser, you should see a click to start text under the Duck Hunter title screen, and a made by JS Legend at the top left corner, which with a half opacity. Now, because our game is score based, we want to keep track of the score of the player and put their best score in the title screen, a bit like the original Duck Hunt did. So here, let's create a best score variable, and let's use KAPLAY's getData function, which allows us to get data from local storage. Here, I'm going to get the data from a key called best-score. At the moment, this key does not exist in local storage. By the way, if you're not familiar, Local storage is where you can store data in the browser that can be used at a later date. So basically a way to save things. But the problem with that is that it is not really reliable. But since this is just a small score-based game, it's not a big deal, so let's use it here. So here, as I said, we're getting the data from this key, which does not exist yet. And we have a statement here using the two vertical bars to, if this is not defined, which isn't defined the first time you open the game, we should set 0 instead for the best score. Now, I think that we don't need the number typing here. So let's remove it for now. So now what happens here is that the if statement, we're going to have an if statement and check if best score is defined. And if best score isn't defined, actually, I don't think you need that since we set it up to 0 anyway. So yeah. So either you can remove the vertical bar 0 and just keep the if statement, where we just set it to 0 afterwards, since it's a variable. And then we use the setData KAPLAY function to set the best score key as an actual key in local storage with the value 0. Now, right below it, we create another game object with some text, which will display the top score. Again, the same logic here and components we're using. You should now be familiar with these components. Let's add a new color to our colors constant object in constants.ts. And once we do that, we can use it here. And here we're going to have a utility function. So let's create a utils.ts file. And in that, create that function that we're going to use to format the score. So in our game, our score is always displayed with a format that is of 6 digits. So to have this, let's create a function that will take in the score as a number and the number of digits we want to format the score in. So first of all, let's create a constant called score as text and convert our score, which is a number, to a string using the toString function. Then let's have a variable called zeros, a variable called zeros to add, which initially is 0, to determine how many zeros we need to add in front of the score so that it fits under the 6-digit format, or the number of digit formats that we want. So if the score as text.length is inferior to the number of digits, we can determine the number of zeros to add by doing number of digits minus the score as text length. So the length is the number of characters in our score as text, as a string. Now let's create another variable called zeros, which is actually a string, strings that is going to contain the zeros that we need to add as a string to the score. Now we're going to have a for loop, and that for loop will just add zeros to our string. Actually, this is not a good way to do it. We should probably just set the zeros to 0 initially, or actually we should the 0 we are adding in the for loop should be a string, a 0 in a string. Sorry for that mistake. And now finally, that way we won't need to in the end return the zeros plus a stringified score. Well, actually, we're going to need this, but something to notice is that in JavaScript and TypeScript, you can concatenate a number with a string by just using the plus sign, which is something that is illegal in other programming languages. So I thought I would just use this, convert it to a string before doing this operation, just to make things clearer in case someone who isn't familiar with JavaScript and TypeScript stumble upon my code base, I guess. Anyway, yeah, so once this function is done, let's use it. So import it at the top of main.ts and pass the best score to it with as the second param, not 0, sorry, that's a mistake, 6, which is the number of digits we want to display the score in. And then finally, let's add a onClick handler. So the way you handle events, there are many ways, and for clicking, you use the onClick function provided by KAPLAY. and it takes a first param, an only param. Actually, yeah, it can take more than one param if I remember correctly. But in our case, we just need to pass to it a function that it will fire when the player clicks. So here we just go to the game scene. So now if I look at the results of that, you can see that if I have the top score displayed in the correct number of digits. All right, so now let's work on the game scene. So in our game scene, which is the whole place where the game takes place, the core of our game, I would say, we're going to first set our cursor using the set cursor KAPLAY function to none, which will basically hide your mouse cursor when hovering over the canvas. The reason we're doing this is that we're going to later replace it with our own. So our own cursor, which looks like a cross and like a cursor from a gun. Now let's create a game object which is going to be the sky of our game. So the background, the bluish background. So to do so, let's create a game object. That game object is going to use the rectangle component. That component is from KAPLAY, and you can set the width and height by passing to it the width and the height you want as params. Here we're using the KAPLAY width and KAPLAY height function to get the canvas width and height. So it takes the full, it's going to create a rectangle that will take the full width and height of the screen, the canvas. Since I told you that by default in KAPLAY, game objects are rendered from their top left corner, that means that the game object will be placed at the top left corner also. So not only is it placed, not only are objects, the origin of our canvas is the top left corner, so the coordinate 0, 0 is the top left, but also the origin of the game object itself is its origin, so it's top left corner. That's why we can just do the width and the height, and we do not need to specify a given position, because by default in KAPLAY, if you don't use the positional component, the pause component, it's just going to place the game object at the top left corner of the canvas. Now, just one thing to note is that the way the space works in KAPLAY is that the further you go to the right, the further the value of x increases. The further you go down the screen, the further the value of y increases. So that's how it works. Now we can use the color component and specify the blue color. So that's going to be the color of the game object in the rectangle. Then we're going to set a tag. Tags are one of the most useful concepts, features of KAPLAY. I mentioned that to create a game object, you use the add function, and the add function takes as its param an array of components. But it can also take something that isn't a component, which is a string. And this string is called a tag, and basically allows you to identify this game object. That means that later on, if you want to get this game object from somewhere else, you can use KAPLAY's get function and pass to it the tag, and it will be able to query and get the game object you need. That's why it's very useful to create tags when you want to be able to get an object. And here we're setting the tag as sky, because later on in our game we're going to need to change the color of the sky in certain situations, so the background, and that's why it is useful here. So now if you look at the result, when we click on our game, you can see that we are redirected to the game scene and we have a nice bluish background. Now let's create another game object, and this time around it's going to be the background sprite. So if you look at our public folder, you're going to see that it's the bushes, yeah, and the trees, and that's what we need for that. So here again, I use the sprite background, which we haven't yet imported. We're gonna do that in an instant. I'm going to use the positional component to set the position to 0 minus 10. This is what looked good. You can experiment with values. And here, actually using the Z component is very important, because we need to make sure that the sky, we need to set the Z value here. Here we set it to 1. so that because later on we're going to have a little cutscene that plays before the game starts where the dog is sniffing around. So the dog jumps into the bushes, and we need to have set up the layer of the bushes, and yeah, so that we can put the dog behind it. So later on it's going to be more obvious. So now let's load the sprite for this, again using the same logic. And now if we look at the game results, now if we click, you can see that nicely the background with the trees and bushes is nicely displayed. You're gonna notice again in this setup is that the UI is basically baked into the background containing the bushes and the trees. The reason for this is because when I went ahead and tried to find the Duck Hunt sprites, they were like that, so I modified them a bit, changing the colors, etc., to have something nicer, and I just left them baked, the UI baked into the image. Ideally, if you were in the control of your own asset creation, you would basically separate them and have the grass as its own layer, etc. You couldn't actually do that if you open up a pixel art editor. Just take the portion where the UI is and just separate that into its own layer, and then fill the rest with green for the background. Anyway, so now let's create our score UI, because you can see that in our background image there is the score UI but not the number itself. So let's add the number itself by creating a game object and storing it in a const called score. Using the add function, we're going to format the score again using the same thing, the positional component. The Z layer this time 2, because remember the background containing the trees and the bushes is on layer 1, so by having it on layer 2 for the score text, it's going to be displayed on top. Then the colors, we're going to set the color red for the text, and then actually it's not the correct position, so I modified the position, and we actually need to modify the color itself. So by just removing the color component, we can have the default color, which is white in KAPLAY. So now we have the score nicely formatted here. Now let's do the same for the round count. So the round count is where you see the red equal in the background image. It's where it's telling you on which round you are on. So here again, we create a game object with the round count stored in a constant called the round count, by the way. And then we use the text component, and here we just display 1 as the text. We again pass in the font options, text options we need. We use the positional component to set the position. We use the Z component to set the layer on which to display it. And finally, the color component to set up the color, which is going to be red. And then finally, it's the duck icons. So you can see in the original image, we have little ducks here that are now bluish because it's actually transparent. It's a cutout of ducks. So what we're going to do is just fill those cutout with white squares that we're going to be able to change the color of later on to red to demonstrate or show the player when they have successfully hit a duck. So to do so, we are going to create a constant which is going to hold a game object, and this game object is going to have the following position. And one new concept, first let's set a variable with the duck icon position x. So here you can notice that the constant we created is duck icons and not just duck icon. Because I'm going to introduce a new concept of KAPLAY. It's the fact that you can create children game object. So attach game objects to parents game object. So there's this parent-children relationship you can have with game objects. So here we have the duck icon position x, which is going to be a variable which we will use to offset each duck icon from each other. So here we create a for loop for 10 duck icons, and then for each of them we add a new game object. The way you create children game objects of a parent game object is you take that game object and use the add method on it, and that's how you create children game object of a game object. That's to be more precise, that's how you create a child, and then by doing this multiple times you create children. So that way We have a little rectangle with the width of 7 and a height of 9. Why this? Because this is what looked good, I guess. Fit well the cutout. Now the position is going to be using the duck icon pause X we used, that we're going to modify at every iteration of the loop, so that each duck icon is cutout square is put next to each other. And then we're going to use a tag using a template string, because we're going to use the tag, to identify each individual square that represents a duck icon, so we can really modify the color of the one we need specifically. And that's why I use a template string using the index, so to differentiate between each duck icon. And then after having created the child game object, we add 8 of offset in the X position, so that there is a gap between each duck icon. Now, if we look at the results, you can see now that the ducks are white in the UI. Now, for this to work out, just to show you, if in case it's not clear, I'm going to comment out the background containing the bushes and the trees, and you can see now what the game looks like without it. And you can see our rectangles representing the duck icons here that were just below the bushes. All right, so I hope this was clear. Now let's create our bullet UI mask. So again, if you look at the image, you can see that in the UI, you have the 3 bullets appearing. What we want to do is every time the user uses one of those 3 bullets, we're going to put a black rectangle that grows to hide 1, 2, or 3 bullets. Now again, this isn't something that you would do normally if you were to design your own game using your own assets. You would probably find something more modular than that. But just in our specific case, this is how I thought I would do it. But really, if we want to offer more than 3 bullets, you want maybe to be able to be flexible with the number of bullets, and that way it would be probably more appropriate to just have a single image of a bullet and then near it a number like 4 or 5 that you just update, and that would be the easiest way, I would say. But since we want to replicate, I guess, clone a old game, I guess we're gonna do it in a old-fashioned way. So here again, we create a game object called bullet UI mask. We create a rectangle which initially has a width of 0, because we're going to grow it gradually later on. So here again, position Z layer, the color being black, by using 0, 0, 0 as our color here. So as you notice, you can use both RGB values or you can use hexadecimal values. So to be quick here, we know that black is just 3 zeros, and that's what I used here. Now let's create our game manager, which is going to be a very important part of the project. It's going to hold all the needed information regarding the game's state. And then later on, we're going to work on the functionality for the mask, the UI mask. The reason we're doing this is because we need the game manager to keep track of the number of bullets that are still left for the player. So here, let's create a function, call it make game manager, and it will return a game object. And it's going to use the state component. So we're going to use a concept called the state machine. It's a very important concept, and it is very useful for dealing with AI, so creating enemy AI, or dealing with animations, etc. It has so many applications. Here in our specific context, we're going to create a state machine with the default state being menu, and then we're going to have the cutscene round dash start, round dot end, dash end, sorry, hunt start, hunt end, duck hunted, duck escaped. These are all arbitrary names I have decided, which are going to act as our states. And the goal of a state machine is that for each of those states, you define custom logic you want to run when the game is in that state, when the game object is in that state. It's a nice way of organizing your code so that you can know, or just really isolate and write the logic for that state in a specific place. So in terms of organization, it makes things much easier to understand as well. But I would say that to truly understand how it works, let's just actually do it, and then a concrete example, I guess, would go a long way to make you understand the concept. So one other thing that you can pass that isn't a component in the array of components of the add function when creating a game object is the ability to pass a JavaScript object, which you can use to define custom properties. So if you're familiar with object-oriented programming, it's basically your private variables, etc. for your class. So here we go, we create a bunch of properties. For example, we're going to create a isGamePaused property that we're going to use later to allow the player to pause the game at any moment. We're going to have the current score property, current round number, current hunt number. By the way, here I make a mistake. Number, the B should be in lowercase. I will later realize this mistake and I will correct it. But if you want, you can go ahead and correct it now so you don't do the mistake. Now the number of bullets left here can be is 3, and we're going to use that later on to keep track of the number of bullets. The number of ducks shot in the round initially is 0. The prey speed is the speed of the duck is initially at 100, and every time a round ends, we are going to increase the speed. Just to make things clearer, the difference between the hunt and a round is that the hunt is after every duck. So there's 10 hunts in a round. You have 10 chances, 10 duck you can shoot. So those are your hunts. And finally, we have the reset game state function that we're going to create, method. So here again, the way you create methods for your game object is just to create the function within the JavaScript object you pass. Here we're going to have one called reset game state. It takes as the first param this, which is a specific thing to TypeScript, because this by default is not typed, and TypeScript is not going to be satisfied by that if you start using this. So that's why you need to create a first param called this and then type it. Here we're going to use the game object type offered by KAPLAY, so this should be imported at the top of the file, and then you can use this.currentScore and access the variables, the properties you defined on top here. And this function, this method, is really used to reset the game, so that if the player wants to play again, they have this reset so that they don't have false values and more bullets than they should have, etc. when they restart the game. And then finally, we just call this makeGameManager function we created, which acts as our constructor, and store it into a variable called a constant called GameManager. And then we're going to export GameManager. So that means we only create this GameManager once and use it in our game everywhere else. So now one thing we're going to do is create our cursor now. So create a constant called cursor, and then call the add function on that to create a game object, and then pass in the sprite called cursor, then of course load that sprite on top of our main.ts file. Once this is done, we can specify the anchor. So here it's very important to use the anchor component so that the cursor is drawn from the center of the game object, so it will correspond to the mouse. Otherwise, it's going to look off. It's going to be positioned off, and it's going to be very noticeable. Then, of course, use the positional component here, but don't specify value. The reason for this is that we're going to set the position using the move_to function that's going to come up later on, and you cannot have access to that function if you don't use the pause component here. So one thing I forgot to mention is that when you use those components offered by KAPLAY, it adds properties to your game object and it adds functionality to it. So because you used certain game objects, certain components, then your resulting game object will have access to certain methods and certain properties that it would otherwise not have access to. That's why here I have no need to put to set the position of the cursor now, but I use the positional component still because I want to have access to the move_to method later on my game object. And then finally, we set the layer to being 3 so that it is displayed really on top of our game. Now let's look at the result. Or before that, let's actually write the logic for the cursor to follow our mouse. To do so, we're going to use an update loop. So a loop is something that is going to run every frame of our game, and it runs 60 times if your game runs at 60 frames per second. In KAPLAY, the way you set up a loop is by using the onUpdate KAPLAY function and passing to it a function that is going to be called at every frame. Just to to make it simple, to explain it simply. So now here in that update loop, we're going to set the score text. So because we use the text component, the score game object can have access to the text property that we can modify. So we can now modify the text. And here we're going to modify the score here by setting the score text to the current score from the game manager. The reason we're doing this, and by the way, I said that we're going to use the onUpdate loop to make the cursor follow the mouse of the player, but we're also going to use this update loop to do everything else that we need to update. So the score text here is one example. Then we're going to use a switch case statement to know which width to give to the bullet UI mask, so we know how much it needs to cover to hide the bullets. So depending on how many bullets left, so if there's 3 bullets left, then the width of the bullet UI mask is going to be 0. Otherwise, it's going to be 8. Otherwise, if there's only 1, then it's going to be 15, covering the whole portion of the UI I mentioned earlier on, displaying the bullets icon. Sorry. And then, so after we have that, to actually make the cursor move to the player, to the mouse of the player, to be at the same position as the mouse of the player and follow the mouse of the player, you can use the move to function and then pass to it the coordinates of the mouse. And the way you do that in KAPLAY is to use the mouse pause function. And because this is in an onUpdate loop, so at every frame, it's going to get the updated position of the mouse and use that and move the cursor to it. So now if you look at the result, you can see that once I click start, I can have my cursor here that is following me around. Now, finally, what we're going to do is we're going to have another onClick handler within the game scene. And this is just going to first have an if statement that is going to make sure that first the game manager is in the state hunt start. The reason we have this .state property is because we used the state component when creating the game manager, because remember, it's a game object, and this offers us the state property that we can read to know in which state the game manager is. And here we're checking if the game manager state is in hunt starts, that means the hunt has started, and that the game manager is not paused. So this is a property that we have defined, so we can just access it here. And in that case, what we're going to do is we're going to first make sure that the game manager, the number of bullets is superior to 0. And then, so first of all, before we continue, this is the reason we're doing all of this is to play the gunshots. So here we're going to load the sound at the top of the file, call it gunshot, gun-shot, and then put the correct path. Now, if the number of bullets is superior to 0, we're going to play that sound, the gunshot sound, and we're going to set the gunshot. The way you play sound in KAPLAY is you use the KAPLAY function. You pass the name of the sound as the first param. The second param can be optionally options, like the volume that you want to use here, the volume, So here we set the volume to 0.5. Now, with that aside, what we're going to do is just, either way, we reduce the number of bullets. So this is the logic to play the shooting sound when the player shoots a bullet, when the hunt has started, because we don't want the player to waste their bullets outside of the hunt. So when the duck is either escaped and or hunted, and then you're waiting for the next hunt. So that's the logic for that here. We have here, and then so the logic to reduce the number of bullets, to shoot the bullets when it is appropriate by using an onClick. All right, so now has come the time to actually write the logic for each of the states we have in our game manager. So this logic is going to be written in main.ts because we need to pull from other aspects of our game, and it's going to be the central place where we will be importing everything. So now what we're going to do is first create a constant, call it round start controller, and this is going to use the onStateEnter method of the game manager. Remember, this is available because we used the state component when creating the game manager game object. So because we used that component during the creation of this game object, we can have access to the onStateEnter method, which we can use to define what logic to run when a specific state is entered. Here we're going to use as the first param the name of the state we want to run the logic for, and it's going to be round dash start. And the second param is going to contain an anonymous function which will contain the logic we need to run when we enter that state. Later on, the reason I'm storing it into a constant, the reason I'm assigning it to a constant, the round start controller, is that for state machines, I have noticed that if you leave the scene, so go to another scene, the state machine still runs. So what we're going to do is we're going to keep track of all those controllers and then cancel them before leaving to another scene. This will come up later in the tutorial. So before we do anything, in our second param where we pass a function, let's make it async, and let's also add a first param in it. So it's going to be isFirstRound, and it's going to be a boolean. This way we're going to be able to run different logic depending on if it's the first time the player or the game goes to that round start scene or not. And this is going to be relevant later on. So within that function, write a if statement where we first check if it is the first round, and if it isn't, we're going to increase the prey speed of the game that the game manager holds. Here we're going to do a plus 50 to the value so that the game will become progressively faster. Now, with this if statement, you can figure out that when we first enter the round start, when the player plays the game for the first time, we don't want to increase the speed of the ducks because it's the first time. And every time a round ends, then we increase the speed. That's why we have this logic to only increase the speed when it's not the first round. So all subsequent rounds, not runs. So now what we're going to do is load our assets. So what we're going to do is first display a message, I guess a UI, telling the player which round they are in. So this is the first thing they see when they should see when they enter this round start state. So to do this, we need to import our graphics and UI for that and sounds for that. So at the top of the main.ts file, use a load sound function call and pass to it the UI appear and the path to that sound, which is also in the sounds folder. Now we will we don't really need to have an image for that, since yes, we have an image that we're going to load later on. So for now, just add a call to the play function from KAPLAY. So by doing k.play and then the name UI-appear, this is the sound, a sound cue that we're going to play when the game enters the round start state. And as soon as we have this sound that we can play using the play function, we are going to increment the current round number. And once this is done, we are going to take our round count game object that we assigned to the round count constant and set some text to be the value of the current round number. Here I wrapped it up in a string, but really, you could do it without that because JavaScript is very flexible. You can just pass a number, etc., and it will convert it to a string. So yeah. Now what comes next is we're going to create the text box game object, which will display which round we're in. So we call the add method and pass to it the sprite component with the sprite text-box. Now we need to import that. If you look at your graphics folder in the public folder, you should see a file called text-box.png, and this is the box we're going to use for our text box UI that is going to display the round number. Now that this is imported, first let's make the game object render from the center, from its center, instead of the top left corner, using the anchor component and setting it up to use the center. And for the position, we're going to have the x coordinates follow the center of the canvas. As for the y coordinate, it's going to be the y coordinate of the center minus 50. So minus 50 means that it's going to be a bit at the top, because remember, the lower the value of y, the higher the value of y, the lower on the screen your game object is, because the Cartesian plane is kind of inverted, I would say. So the y-axis increases the further you go down. Finally, we put the Z layer using the Z component to 2 so that it appears on top of the background and the bushes and the trees, etc. Now we're going to add a child game object to that text box by just using the add method on that text box and passing to it an array of components. The component we're going to use is the text component, and then pass to it the text round with the text options we need, so the NES font and the size of 8. We are going to have the anchor set to center again for making things look nice. And the position is going to be 0, minus 10. And something to remember, I don't think I have mentioned this before. The position of a child game object is always relative to its parent. That means that 0 and minus 10 here are relative to whatever the current position of the parent is. So you take the parent's position and you add to it those two values, 0 and minus 10, on each axis. Now we're going to add a second child to that game object, that text box game object, and this time around it's going to be the current round number. Again, same logic. And here I'm repeating the same text options over and over again. So you know what? Let's go to the constants.ts file and just create a font config constant that we're just gonna use once here, set once, and then import it in our main.ts and use it, replace it everywhere else. So now that we have this done, let's add a call to the wait KAPLAY function, which is going to wait 1 second. So we want the game to wait 1 second before the actual game starts. You can do that using KAPLAY's wait function. There is two forms of that function: the async, the await version, async version, and the continuous, I would say the normal synchronous version, where here we're going to use the await version. Now what we're going to do is, after 1 second elapse, we're going to destroy the text box game object, because we want to basically remove that UI, and we're going to make the game manager state machine, which was created using the state component in GameManager.ts, enter the hunt start state. And you can achieve this by calling the enter state method. And this is how you move from one state to another, is by calling this enter state method. Now let's define the logic for, well, actually, you know what? Let's first test this out. So just right below, outside of where we define the round start controller, call GameManager.enter state, with the round start state, which is the state we just defined here. And this will force the game to go into that state. Like if we look at the results, you're going to see that you have round 1 and then it disappears. And that's what we want. We have entered the other state. So now let's define the other states. So the round, not the round start, the round end controller which again will follow the same logic, same structure. Let's have a to-do. Let's define them all, and then we'll fill each of them later on. So round end controller, and then hunt start controller, hunt end controller, duck hunted controller, and duck escaped controller. And that's basically it. So if I look back at GameManager.ts, you can see that yes, we have all the state covered. Now there's one we don't have. I think the cutscene, and the cutscene state, we do nothing with it. And the menu state is just the default. So when you define a state machine using the state component, you have to provide a default state and you as the first param, and you also have to put it in the array containing the list of all possible states, which is accepted as the second param of the state component. Here we have the cutscene one. In the end, I don't think I ever used this, so it's not necessary to keep it. So you can comment it out or just leave it here. It won't do anything. So yeah, initially I thought I would use that state to run some logic, but in the end we don't. I didn't do it. So now has come the time to work on our entities, so the duck and the dog. So let's first work on the dog, which is going to first play a cutscene where the dog is sniffing around to find ducks, and then once a duck is detected, the dog will jump into the bushes. So to achieve this, let's first create a folder. This folder is going to be called entities, and let's have two files, dog.ts and duck.ts. So let's go to dog.ts. Let's first import our context, KAPLAY context, using import k from KAPLAY CTX. Let's define our constructor, which is going to be a function that is going to be responsible for making the dog. Here I'm going to just call a function, call it make dog, and then have as the first param a position. Here I'm going to type it as a vector2. So vector2 is a type that you can import from KAPLAY. It's essentially a data structure offered by KAPLAY, which holds an x and y coordinate and basically allows you to easily work with that. So since the typing is already offered by KAPLAY, let's use it here instead of inventing our own. Now we're going to return a call to the add function and an array of component. For now, let's keep it empty. We're gonna just write some other logic right before. So let's first create a const called sniffing sound. Here, what I'm gonna do is I'm going to call the KAPLAY function with the sound sniffing, which we haven't yet imported, and a volume. So the play function in KAPLAY allows you to play sound, as we have seen previously. It takes as the first param the name of the sound you want to play that has been imported using the load sound function. And as optionally a second param, you can specify values like the volume. Here I set the volume to 2 because that is what sounded good when testing the game. Now here what I'm going to do is I simply play the sound and immediately stop it. The reason I'm doing this is so that I can have the sound available at all times in that constant, assigned to that constant sniffing sound, so I can later on in my logic for the dog logic play it again. So it's kind of a way to load it in. So it's not the right terminology because to load the sound you use the load sound, but actually to keep it in standby, I would say I first assign it to a constant, and the only way you can do that is by playing it once, and that's why we play it and immediately stop it. So for the player, they will not hear anything. I'm going to do the same for the barking sound. So here's the same logic applies, and this time around we don't need to set the volume. The default volume of that audio was good, and we immediately stop it. And finally the laughing sound, which again will have the same logic. So before we continue, let's go back to main.ts and import all of that sound. Let's first import the sprite for the dog because we're going to need that in a moment. So our dog here is in a sprite sheet, which is an image containing multiple frames. So if you look at it, it's a 4:3 image, so 4 frames per row and 3 frames per column. So now the way you're gonna tell KAPLAY to divide this sprite sheet into different frames is by passing a third param to the load sprite function, which is optional, and then setting the slice x property and the slice y property. And as I mentioned, it is 4 frames per row. So slice x is going to be 4 and 3 frames per column, which is why slice y is set to 3. And then finally, you have an anims property you need to define, and in that you can define your animations. So here I have an animation that I have decided to give it the key of search, and you pass to it an object, and that object contains various info or data regarding that animation. For example, our search animation starts from the frame 0. So what happens is that KAPLAY will slice your image into multiple frames, and then it will number them starting from 0, from left to right, top to bottom. That means that the first frame to the left is 0, then 1, 2, 3, and then you go down like that. Here, so that's why it's important here to specify the from property, so that we want the search animation to start from frame 0 to frame 3. So this will be the animation for the search, the frames for the search animation. And then we set the speed, which is the rate at which the animation plays. The more you increase this value, the faster the animation will play back. And then here we decide to make the animation loop indefinitely once it plays by setting the loop property to being true. So we do the same thing for the other animations, just it depends, the frame numbers will change depending on the animation, of course. And you might have noticed that some of the animations only have one frame, and when you have only a single frame that you want for that animation, you can just give the number of that frame immediately instead of passing an object to the key you want. Alright, so now that our animations are done, are set up, we actually have to import the audio, but before that, let's have our game object for the dog set up. So in our array passed to the add function, let's use the sprite component and load the display the dog sprite. Let's set the position by passing the position in the make dog function to the pause component. And then let's have a state machine specifically for that dog, which will allow us to define its logic and its AI basically. So this is how I was able to have this little cutscene in the beginning of the game where the dog first goes around and sniffs until a dog is detected, and once the dog is detected, the dog jumps, and etc. So that's why the state we're going to use is the search state, which is going to be our default state. And then in our array, remember, you need to provide all the possible states, so you have to provide search again. And then here I decided on the sniff, detect, jump states and drop state, because the dog jumps in the bushes and then drops behind them. And the layer, we need to set the layer initially to 2, and this, because we use the Z layer component in our game object, we're going to be able to modify its value later on, and this is how we can achieve that the dog is first in the front on layer 2, and then it's going to go behind the bushes by changing the layer to layer 0 or 1. And then finally we pass an object to set some properties and our methods for our dog. So here I set the speed to 15. I create a method called search for ducks, which is going to run initially at the beginning of the game before the game actually starts. And this will be responsible for having the dog move around and then sniffing and detecting and then jumping and dropping behind the bushes. So in this function, again, we need to type this. This is a TypeScript thing, as I have explained previously. It will be actually removed when it is compiled to JavaScript. So here, let's declare a variable called number of sniffs. The reason we're doing that is that depending on how many sniffs the player is going to hear, we're going to do something different with the dog. So here, let's define our states logic for each of our states we just defined. So for the search state, we're going to first play the search animation. So this is something that might confuse you because in KAPLAY, k.play is the function from KAPLAY to play audio sound. But when using the play method on the game object is to play an animation. Here we are playing the search animation and not playing a search sound. Something to keep in mind. You need to be very careful about this because sometimes you can easily be mistaken and then get confused. So now let's load our. Even I got confused. I initially wanted to load the search sound, but it's not. There's no search sound, so it's a sprite. Anyway, let's load our sounds that we had: sniffing, barking, and etc. But first, let's do it with a sniffing sound. Now let's go back to our search state logic. Here we're gonna use the wait function. This time around, we don't need to use the async version. Let's just use the synchronous version. So just to demonstrate, you can use the synchronous version by doing k.wait and then pass as the first param the number of seconds you want to wait, and then the second param is going to be the function that is going to run. If you were to use the asynchronous version that uses a wait, what you have to do is just you pass, there's only one param to pass, which is the time to wait. And then once the time has elapsed, whatever is below the call to wait will run. So here we will enter our sniff state after 2 seconds. So first the dog searches while moving, and then he's going to sniff first, and then, okay, no dogs were found. Sniff again, no dogs were found, and then I think a third time, and then, a duck was detected, etc. So that's why we do this. Now let's define what happens every frame when the dog is in the search state. So you might be familiar with the onState enter, but this is onState update method, which allows you to have more granular control and run a function every frame while you are in a specific state. So here again, this is used to make the dog move from left to right, and the way you move things in KAPLAY is by using the move method on the game object. You pass to it 2 params. The first one is the rate of movement to the x in the x-axis, and then the rate of movement on the y-axis. So here I pass the speed on the first param, which means that the dog will move only horizontally and not vertically. That's why I set the second param to 0. Now let's define the sniff state, the logic for when we enter the sniff state. Here again, I'm gonna increment the number of sniffs, variable we had created earlier on. Then I'm gonna play the sniff animation on my dog, and this is what so I made another mistake, by the way. It's not sniff, it's sniffing for the sound, and there is this actual sniff animation. So that's why let's load the barking sound now, and the final one, which is the laughing sound as well. Now for the sniff animation, we don't have to define anything because it's already included in when we loaded the dog sprite sheet. Here we play the sniffing sound, we wait 2 seconds, and then we stop the sniffing sound, and we first check if the number of sniffs is equal to 2. If it's the case, that means we enter the detect state, and that means that the dog has detected a duck. This is all a scripted event, like a cutscene, so that's why it is hard coded to 2 sniffs. And then we return early. By doing this, you make sure to prevent the logic that comes after to run. And this can occur where you enter a detect state and then the code still runs in the onState enter of the sniff state, and you will find yourself in the search state instead. So be careful with that, with state machines in KAPLAY. So in the case it's not, the number of sniffs is not equal to 2, we enter back into the search state, and this will rerun the logic for sniffs, and then we'll hear the sound again, etc. Now for the detect state, we again use the onState enter function, and then we play the barking sound. We also play the detect animation, then we wait 1 second, we stop the barking sound, and then we will enter the jump state. For the dog will enter the jump state. And then finally we define the jump state, and we again play the barking sound again. By the way, the reason I'm doing this in a specific order, etc., is just to replicate the original Duck Hunt, which had an exact similar cutscene at the beginning of the game. And then we play the jump animation, and we wait 0.5 seconds, which is what looked good. We stop the barking sound. We then use the use method on the game object to change the Z layer. So I'm not sure, but I think the reason I did this is because you cannot actually change the Z layer. Otherwise, try doing this .z equal and then change the value. If doing this works, that means you should do the way I just said instead of using the use method here. The use method here is when you want to add components after the fact, after having created game objects. You use the use method. So for example, you created a game object with 4 components, then later on you need some other ones, then you use the use method here to add new ones. And then finally we enter the state, the drop state, and in this we're going to we don't need to have an onState enter function to run here. We only need to have the onState update because we want to move the dog every frame downwards so that it looks like actually, first we need to make the dog look like it's jumping and then go down. So the way we do this is first we move the dog using the speed on the x-axis to 100 and then the y-axis -50. This will make the dog move to the right and up. And this gives the impression that the dog is jumping. Then as soon as we enter the drop state, so this for the drop state, we actually need to have an onState enter. And by the way, we actually did use a onState enter definition for the jump sound. Sorry, I forgot about it. So now in the onState enter for the drop state, we're going to have a sync function and use a tween. So a tween allows us to gradually change a value from a specific value, original value, to a target value in a certain duration using a certain easing function, which is a rate of change, which can make your game look really good if you use them well, because you can have all kinds of effects like an ease out bounce, etc. And the way the tween function works in KAPLAY is that it takes as the 4 params. The first param is the original value. Here we're going to pass the y position of the dog. Then the target value, here we want the dog to be at y position equal to 125. This is what looked good while testing the game. The duration, let's do this in 0.5 seconds. And you need to pass actually it's 5 params, not 4. You need to pass a function that takes care of modifying the value. So here this function is called at a rate that follows the easing function we're going to pass in the 5th param. So here we just take the new y, or the new value, which is passed to that function we passed as the 4th param, and set it up to be the new value of y. And then finally, for the easing functions, you can access all the possible easings offered by KAPLAY by using k.easings and then dot, the name of the easing. So let's use the simplest one, the linear one. So those follow math functions in case you're wondering. Now, what we're going to do is have our game manager, and this, make sure to import it, by the way. And the reason we want this is to make the game manager enter into the round start state, sorry, not scene. That way, we make the cutscene end and immediately go to inform the game manager that, okay, now the game can start, the round can start. And it's the first time we enter that round. That's why the second param is set to true, because in the game manager, you remember we had a param that we created to make sure to have different logic depending on if the if it's the first time or not, and this was defined in main.ts. So now let's write our second method for our dog, which is going to be a slide up and down method. This will allow the dog to slide up. So this occurs when the dog, when you, for example, shoot a duck, or even when you fail, what will happen is that the duck will either flee or get shot and then fall to the ground. And then after that, the dog will slide up from the bushes. And depending on if you were successful, then he will rise with the duck in his hand, the dead duck in his hand. While if you failed, then the dog will rise up and laugh at you. This was something that was in the original Duck Hunt game. Here again, to do this, we use a tween. And again, like I mentioned, it's the same principle. We first slide up with the first tween, where the position, the target, the original value, the target value, the duration, the function that actually changes the value, and then the easing function that will determine the rate of change. Then we have an await. So the reason we have an await here, we use the await variation of the tween because there is a synchronous version, is because we want the first tween to run, make sure that the dog rises up, and then wait 1 second using kwait, and then make the dog rise down. So go down, not rise down, go down. Again, using the same logic. So now that we have that, let's write one other method. And this one is to catch the fallen duck. This will just play the catch animation, which is just a single frame where the dog has the duck in his hands. And that's it. And let's load our sounds we need. So the successful -hunt sound, if you look in your public folder, you should see it. I'll load that in main.ts, then play that sound, and then let's, once we play this, we will call the slide up and down method we just created, and you can have access to it by using this dot slide up and down. And then finally, we're gonna make our game manager enter the hunt end state. As I explained earlier on, a hunt is a single try, while a round is 10 tries. So here, after having successfully hunted a single duck, we can consider the hunt to have ended. And then the other final method, sorry, there was one more, is the mock player. And again, this will just play this sound, the laughing sound, sorry, that's the proper pronunciation, I guess. And then call the slide up and down function, and then also enter the hunt end. So depending on which function we call, the dog will display different animations, which again, depending on the situation. And then I forgot to add in the mock player, play the mock sound, not mock sound, the mock animation where the dog is laughing. And that's it. And now we can go to main.ts and create a constant that we will assign to it the dog game object, so call it dog, and then make sure to, of course, import make dog at the top of main.ts. Then pass to the make dog function a vector2. You can create a vector2 on the fly using the vec2 KAPLAY function, which takes in two params, or either the x and y coordinate. So here we're gonna have 0 for the y coordinate, the x coordinate, sorry, and the center of the canvas as the y coordinate. Then we're gonna call the search for ducks method immediately after having called our make dog function. And that's it. So now before we test things out, let's add the logic for to cancel all the controllers we have here when the player leaves the scene. So that's why I'm going to use the onSceneLeave KAPLAY function, and then have our round start controller, round end controller, hunt start controller, hunt end controller, duck hunted controller, duck escaped controller, and the game manager reset game state function. So all the controller are going to get canceled using the cancel method, which is offered by KAPLAY. And that's it. That's how we reset our game. So for example, when you go to the game over screen and then come back, everything's going to be fresh, I guess. Now, if we look at the result of that, so let's click. We have our dog that sniffs around multiple times. And then detects and then jumps. And then we have the round 1. And that's it for now. We can shoot the bullets, but nothing more. So now that we have completed the logic for the dog, let's do the same for the ducks, or the duck. So in our entities folder in duck.ts, let's start writing the logic for the ducks. So first of all, I will first import the K, or the KAPLAY context, and then create a constructor function called make duck. And this is, again, going to have mostly the same logic, but it's going to actually take different params. Actually, the logic is a bit different from the dog, to be more precise. We're going to have 2 params. The first one is going to be the duck ID. This is a way for us to know which duck is which amongst the 10 ones in the run. So the 10 ducks. We want to be able to differentiate between them so that when we shoot one, we can know for which duck icon to color red in the UI. So that's why we're going to pass the duck ID as a string. And the speed here, we're going to pass to the make duck constructor here so that we can modify the speed of the duck in further rounds, so to make the duck faster. So first of all, let's have a constant containing the starting positions, and it's going to be an array which is going to contain various positions from which we can launch the duck from the bushes, so that it adds a bit of variety to our game. Then we're going to return, of course, a call to the add KAPLAY function to create the game object with an empty array for now. Now, in our starting position, every one of those positions is going to be a vector 2. And let's write them out here. So here are 3 positions I've decided to add. You could tweak those values if you want after having followed this tutorials. Yeah, so that's arbitrary values that looked good. And you also need to make sure that it looks like the duck is coming from the bushes out to the sky. So now what we're going to do is have another constant. This time around it's an array again, but for fly directions. We're going to have 3 vector 2s determining directions from which the duck will go towards, in which direction they're going to fly. So here we're going to have normalized vectors. So this is something a bit of a math, you need a bit of math knowledge here. So we have -1, -1 on the X and Y axis. Here you need to see them as angles, I guess, from which the duck will follow. And you don't really need to know your math related to vectors here, but it's helpful to learn a bit more about linear algebra. Anyway, so let's have our fly directions here. And now we're going to have another constant, and it's going to be the chosen position index. So chosen pos index. And this is going to randomly select from the starting pos array a single position we're going to use for that duck. So here we use the randy KAPLAY function for that. A random stands for random integer. And we pass to it the array, the length of the array, and it's going to give us a value between 0 and the length. And of course, it's going to exclude the outer bound, I think. I hope so, if I remember correctly, so that we can never have an out of bound index. And then we're going to do the same for the chosen fly direction index, but for the fly directions array. Here we're going to have our duck sprite loaded here with a default animation. So before we proceed on, let's go back to main.ts. And in main.ts, let's load our duck sprite. Here again, I do it quickly. And again, it's the same principles. You can use a string for the key, by the way. You're not constrained to a single word for each of your animations. So yeah, that's that. Now, if we go back to our duck.ts file, and here we set the default animation to flight dash side. We set here an area component. So the area component is a very, I would say, crucial component when working with KAPLAY. It creates an automatic hitbox for your game object, which allows you to detect collisions. Very important. And here, not only does it does this automatically, the area component, but you can also optionally pass to it a specific shape you want for that hitbox. And this is what we're going to do here. I'm going to pass a rectangle by using the rect constructor from KAPLAY and create a rectangle which takes as the first param its position relative to the game object that uses that shape, that hitbox. Here we just pass a vector2 with the value 0 in it, and it's going to replicate it for both the x and y axis. So basically what we're saying is that we want the rectangle shape hitbox to be at the same position as the game object itself. Then for the second and third params, we set the width and the height of the rectangle. Now we use the body component right after. The body component is another crucial component in KAPLAY. It allows you to make your game object susceptible to gravity, and it also allows you to have access to methods that we're going to need here. In this game, I don't think we use gravity at all. We just move programmatically the objects, the ducks, etc. But we still need to use the body component, if I remember correctly, because we need access to certain methods that are only offered when you use the body component. And finally, we have the anchor component to center the game object in its center rather than its top left corner. And finally, the position, we set the position by taking the starting pause array and passing the chosen pause index. And finally, we're going to have also a state machine for the duck, which is going to contain 3 states: the fly, shot, and fall states. And finally, a timer component is going to be used, which will allow us to have timer methods on that game object. And finally, again, I say finally a lot, but I think that's the true finally, I guess. We're going to have the off-screen component, and this off-screen component is going to destroy the duck when it leaves the screen to free up resources. It takes optionally, you can pass to it a game object, not a game object, a JavaScript object to tell it how to behave. So here we set the destroy to true. That means that when the game object is off screen, you're gonna destroy it and not just pause it or something like that. And you're gonna destroy it when the distance outside of the visible screen, the canvas that is visible by the player, is 100 units. Now we're gonna add an object here to define our properties and methods. So the fly timer here is going to be used to count the duration of time in which the duck is trying to avoid the hunter, the player basically. Once this time is elapsed, we're going to, so that's the second property, time before escape. After 5 seconds, we're going to make the duck leave the screen. That means the player has failed that hunt. The duck ID can be taken straight up from the params of the makeDuck function. This is a JavaScript feature, by the way, so that you don't have to repeat duck ID colon duck ID. And then for the fly direction, here we're going to set it initially to null, and then we will set it up later on in our methods. As for the speed, same as with the duck ID, we pass it directly from the makeDuck param, speed param. Quacking sound, flapping sound, etc. are sounds that we're going to add later on. So now let's create our first method, which is going to be the setBehavior method. And in that, we're going to set the fly direction to be the fly direction array and then the chosen fly direction index. And then here we're going to make the duck face the correct direction. The way we do this is if the x component of the fly direction vector is inferior to 0, and then we will flip the image like a mirror on the x-axis, and that way, that way the duck will face to the left to the left, because by default I think the sprites face to the right. Now we're gonna play the quacking sound with a specific value. Let's import it in our main.ts file. We're gonna do the same for the flapping sound. And then here we're gonna play the flapping sound, which is basically the duck flapping its wings. And then we're going to have special options here. We're gonna set the loop to true. So you have two options. Either you do this, so setting the speed and the loop here. You can do it when you define the, actually, never mind. This is a sound. Again, sometimes I confuse myself because the API for dealing with animations and the API for dealing with sound is very similar syntax-wise. Here we are repeating the flapping sound indefinitely at a speed of 2. So we are making the sound plate at twice its speed, normal speed. Here again, we're gonna use the onState update, onState enter, etc. to define the various logic we need for each of our states. So here we go. Now, of course, we need to import our game manager. And here we're gonna have an onClick, which is onClick can both be a function from KAPLAY and a method on a game object. So if your game object uses the area component, you can use the onClick method. So here you pass to it a function that is going to run every time the player clicks on the game object. Here we check if the number of bullets is inferior to 0. If that's the case, we're gonna return early, because that means we don't want to make, so for example, if I no longer have any bullets and I try to shoot the duck by placing my cursor on the duck, then we need to actually check that there are bullets left. Otherwise, we're gonna make the duck shot, even though it shouldn't be the case. So that's why we return early and do not run the logic needed for when the duck is actually shot. So here we're gonna if it's not the case, that means we have bullets, we're going to increase the current score by 100. We're gonna play what's the sound? The shot sound. Actually, no, we're gonna play the animation of the duck being shot, which is also named shot. And then we're gonna enter the shot state. Now we're gonna get the sky game object, and the way you can do this in a very handy way is to use the KAPLAY get function, which allows you to get a game object or all game objects that have a certain tag. So it gives you all possible game objects that have the tag sky. If you remember, at the beginning of the project, we defined this in main.ts when we created the sky game object. So here, by calling k.get sky and then passing the taking only the first index, because there should be only one, because remember it returns an array, then we can get our sky game object. And then we're going to have a loop, and the reason we can use the loop method on the game object is because we used the timer component. You could have decided to use the KAPLAY loop function instead. I think there is one. The reason we want the loop as a method of the game object rather than using the loop function from KAPLAY is because we want to destroy this logic, cancel this logic automatically when the duck leaves the screen. It's going to do this for us. That means we don't have to worry about keeping track of our loop logic here and making sure to free it when the duck is gone, for example. So that's why I used the timer component and use the loop method here. So now in this loop, we put as the first param the frequency of that loop. So every second, we're gonna run the function passed as the second param. So here what we do is we just increment the fly timer property, custom property we created by 1. Now if the fly timer is equal to the time before escape, that means that the time has elapsed and now it's time for the duck to flee. Then we're going to change the color of the sky. And to do this, we're going to use the sky.color and then set the color using hexadecimal. And the way you do this, if you're not using RGB, is to use the color constructor and from hex method. And then here we're going to go back to our constant.ts file and just write the hexadecimal code for the beige color and then use it here. Remember to import the colors constant at the top of the duck.ts file. Then finally, we're going to have a method called onExitScreen, which again, this method is available because we use the offScreen component when creating the duck game object. It takes as a param a function, and that function will run as soon as the duck exit the screen. And what we're doing in that function is just to stop the quacking sound and the flapping sound as well, and to change the sky back to the color, the original blue color. Now you might be wondering, why did we change the sky color in the first place? That's something in the original Duck Hunt game. When the duck is now escaping, so after some time has elapsed, the sky will change colors for a while and then the duck will escape and then the hunt was basically failed. Now we're also going to reset the number of bullets for the next hunt, because remember there is 10 hunts in a single round. So let's set up back the number of bullets and we're going to enter the duck escaped state. So now let's write the logic for the shot state. So here we have the game manager and we're gonna increment the number of ducks shot in round, and we're gonna play the shot animation of the duck. Then we're going to actually, we don't need to play the shot animation because we do this earlier, so we don't need that. We're going to stop the quacking sound, we're going to stop the flapping sound, and we're going to wait 0.2 seconds, and remember to make this async before entering the false state. Now before doing the logic for the false state, let's do it for the fly state. So every frame, that's why we use an onState update. We're going to first check that the fly timer is inferior to the time before escape and that the position on the X coordinate of the duck is superior to the width of the screen plus a small offset of 10, and that the position is also inferior to -10. The reason for that is to make sure that the duck is not so the reason for this is that when the duck is near is outside of the screen with a certain little gap, we're gonna make the duck come back, bounce back, a bit like the DVD player logo that you see, the famous DVD player logo that bounces off the screen and comes back. This is the same logic we do here. So here we're just gonna set the fly direction X coordinate to X component, sorry, to be the inverse, and then for the Y we're gonna just have the same value, and this is going to achieve the DVD player kind of logo bouncing off effect. Also, we just gonna reverse the image, the sprite of the duck as well, to give it the mirroring effect so that it goes into the other direction, and you can achieve this without needing to know if the duck is currently flipped or not by just setting the flip X property of the duck to be the inverse by using the bank sign before the this.flipX. And then finally, we're gonna get the current animation, assign it to a constant by using the getCurAnim function method and getting the name. And if the name is equal to flight side, then we're gonna change the value to flight diagonal, and otherwise we're gonna make it flight side. The reason for this is that when it bounces back, it's going to fly in a diagonal fashion. And then finally we play the current animation. So yeah, so we get the current animation depending on if the current animation is the animation that is already currently playing is flight side. We're gonna change it to flight diagonal, otherwise we're gonna keep it to flight side. That's what we're doing here. And then finally we play that animation by passing the current anim to the play method. Now for the Y position, so this is horizontally. Now vertically, we're going to do something that's very similar. And again, but just for the other, the other direction. Now, if we, now for actually moving, so now that we have set the new fly direction we want in either cases, either on the horizontal or vertical axis, what we're going to do is to actually move. Since we're in an on-state update, so every frame this will run, we're going to use the move method from KAPLAY, which I think is there because we use the body component. Try the same logic without, try after this tutorial, removing the body component from the duck and try to confirm if it was actually needed, because I might have added it without realizing if it is actually needed. Anyway, so to move the duck in the direction we want, we're gonna pass the direction to the move function. This is another way of using it, and basically it's a vector 2. And now we're gonna scale it according to the speed. So remember, the fly directions were -1, 1. Basically, they were normalized, so the value was only between 0 and 1. And either negative or positive. By using the scale function here, or method, we can scale that value to correspond to the speed. And I think, again, if the fly direction is a vector 2, you can skip on wrapping it inside of another vector 2. That might have been a mistake on my part as well. So now for the fall state, when we enter on state enter, sorry, here we're gonna make the fall sound play. And remember to import that sound in main.ts. And then play the fall animation. And then for each frame, using onState update for the fall state, we're going to move the duck that is now falling only in the vertical direction, I guess, vertically only, setting the first param to 0 on the x-axis, and this dot speed for the y-axis, so that the duck will fall. And then finally, if the position of the duck on the y-axis is superior to the height -10, then we can be sure that the duck has fallen to the ground. And now we can play the impact sound. So before doing that, of course, remember to import that sound in main.ts. And then once the sound is imported, play it and make the first make the fall sound stop, and then play the impact sound. Then destroy the game object by using the destroy KAPLAY function and passing into it this, because this is the game object itself, the duck game object. And then finally change the sky color to being what color we need here, to being blue, in case it weren't blue. So in case where the duck is trying to escape, is starting to escape, but you shoot it, and then we need to actually change the sky back to blue. Make sure that the sky is back to blue, regardless anyway. And then finally, we're going to get the duck icon specific to that duck. That's why we use the duck ID here. And remember, when you use the get function, so if you want to get a game object that is a child of another game object, and you want to get it using the get function, you need to set the second param with an object, a JavaScript object, that has the property recursive true, so that it is going to search for game objects even within other game objects, so the children of game objects. And then since we expect only one duck icon to have the specific tag here, we're gonna just simply need to get the first index, the first element, and that is going to be our duck icon. Now, of course, if a duck icon is defined, make sure this for TypeScript to shut up, we're gonna have the duck icon color and set it to red using the, again, from hex method. We wait 1 second, and then we enter the duck hunted state from our game manager. Now let's write the logic for the hunt start so that we can actually see our ducks. So here I'm gonna use the game manager and then set the current hunt number, increase the current hunt number. As soon as a hunt start, we do this. Here again, I made the mistake to call the property current hunt number with NB being capital letters, but actually I correct this later on by having the N capital and the B not capital. Regular basically, and this isn't a big deal, but if you were following along, just make sure to have the exact same thing, otherwise you're creating a new property with that value, different name, and this could cause bugs and you might not know why. Now let's call our duck. Let's create our first duck here by calling the makeDuck function and assigning it to the duck constant. Here again we're gonna have the ID, which is going to correspond to the current hunt number -1. And now, because the duck icons are numbered from 0 to 9, that way we can have the duck icon with the duck with the ID of 0 is going to correspond to the first duck icon. That's why it is -1 here. And then the prey speed from the game manager, we pass it here as well, so that in further rounds, when we re-enter the hunt start state, the prey speed value could change, and that's how we make the duck go faster. And then we call the setBehavior method. And now if we look at our results, so we have our little cutscene in the beginning, and then once the dog will jump, round 1 starts, and then there is and nothing happens for some reason. There is an issue. So in the next part of this tutorial, we will fix this, this issue. All right, so the error that I made was at line 65 in duck.ts. The issue was that the scale function method is called within the vector, the fly direction. It's a method on the fly direction vector. So just do what you see on the screen. And by the way, I think that fly direction is a vector, so you might not need to wrap it using vector2, but I'm not sure. So now we can look at the result. If I click, we have our cutscene. Then, let's wait for the cutscene to end. Then the dog will jump, and then round 1 starts, and then we have finally the duck that comes out, and then we can try to shoot the duck, and the duck fell, and now for some reason the dog is not rising up, and that's an issue. So we need to fix that, or actually I think we haven't written the logic for that. So in hunt end, I think that's what we're going to do. In hunt end, create a constant called best score, and we'll just get the best score from the local storage. And then if the best score is inferior to the current score, but before that, wrap the get data call to be with the number constructor, so that we make sure that the best score is a number. Because remember, here get data can return either null or none or something, or the data we want, so it's not specified. So by making sure that we have a number, we're pretty much sure that we're gonna get a number, but just so that TypeScript shuts up, we need to do this. So now if the best score is inferior to the current score, we set the best score to being the current score that is available in the game manager. Now that's after a hunt end. Now, so that means that every time we end a hunt, we update the best score. In case so we update it so that at the end of the round, we will have the up-to-date best score. Now, if the game manager current hunt number, again, the same issue we had with number, it should be capital N, but non-capital B, is inferior or equal to 9, that means that we can enter into another hunt by going to the hunt start state. The reason we're doing this is because if we were to have the current hunt number to being superior to 9, that means that we have actually exceeded the number of hunts in our round, which is supposed to be 10. So we return early because by default, if none of these if statements are true, we will just have our game manager a current hunt number, and this is where I actually fixed the issue. We're going to set it to 0, and then we're going to enter the so first I need to modify everywhere else where I used current hunt number wrongly with the wrong syntax. But after that, we can go to the round end. We're gonna first write the logic for the duck hunted state, and then we will write the rest of it. So first of all, for the duck hunted state, we set the numbers of bullets left to being 3, and then we play the catch fallen duck function method that we had for our dog that we defined in our dog logic. Then we will, in our duck escaped state handler for our game manager, we're going to have the function mock player, the method mock player from the dog run here. And that's it. So now by adding those two things, we can go and test our game again. So now if I click to start, and now we have our cutscene again. So yeah, this might be, I should have probably written some logic to skip the cutscene, but anyway, that's too late. You can do this as an exercise. So we shoot the duck, and then the dog will appear on top, and we can see that the duck icon has become red. Now again, if the duck escapes, you see that the sky changed the color and that the dog laughed at you. And here we go. We have, I think, the full gameplay. You can see that the score is updating, and the number of bullets, the mask is also hiding the bullets icon to basically tell you that there's only like 2 bullets left or 1 bullet left, etc. So now let's try to complete a round. We have enough to pass to the next round. So let's just, wait. Just to see the bouncing in action. And the dog laughing at you. And now nothing happens. That's, I think, because we haven't written the logic for when the round ends. So for round end, if you go back to the round end controller definition in main.ts, we're going to first have an if statement where we need to check if the number of ducks shot in the round is inferior to 6. If that's the case, that means that the player has failed the requirement where they need to have at least shot successfully 6 ducks before moving to the next round, to move to the next round. So here we go to the game-over scene that we're gonna define later on. We have defined it, but we're gonna fill the logic for it later on, and we return early. So if that if statement is not true, that means we're gonna first check if the number of ducks shot in the round is equal to 10, and we do this to give the player a bonus. So we're gonna increase the current score by 500. That's a bonus. I think it was like that in the original Duck Hunt game. Finally, in either cases, so if regardless of if the number of ducks shot in the round is 10 or not, we're gonna reset the number of ducks shot in round to 0. And for each of the duck icons, we're gonna color them back to being white by passing a color component with the RGB values 255 on each of the color channels, which corresponds to white. Then we're going to enter the round start state again. And now if I test the game again, and I'm just gonna fast forward a bit, and then you can see I'm just gonna fast forward to the point where we are in the last, here, and then round 2, and then you can see that we have our bullets back, and that the score is keeps increasing, and that the R equal is now 2 instead of 1. So now we can say that we have a fully functioning gameplay of the game. Now there are a little bit of finishing touches we need to add. And as you can see that the ducks in the round 2 are faster than round 1. If I skip around and go to a further round, so by the way, one thing I forgot to mention is let's activate debug mode here with the F1 key on Windows and Fn plus F1 on Mac OS. You can see that there is a box drawn where the duck is, and this is its hitbox, sorry. So now, you can see how handy it is to have a debug mode. We will have to deactivate it later on before going to production. And you know what? Let's stop here. So now we're gonna go to the game over definition of the scene, and we're going to add a couple of. Before that, let's add the sound, the forest ambience sound. So there is this sound called forest-ambience in the public folder, in the sounds folder. Let's import it here and play it in main.ts. So here I set the volume to 0.01 with a loop being true. So that's what you need to do if you want a sound to repeat itself even after it ends. Of course, import it with the load sound function. And this shouldn't be new here, this concept of importing sounds. And now in the on-scene leave, make sure to add this so that we can't, not cancel, we stop the sound when we leave the scene. Otherwise, the sound will continue to play even if you leave and go to the game over scene. So we don't want that. This is for sounds that loop. If your sound were not looping, you wouldn't need to have this, need to make this call. So now if I play our game, you can hear you can barely hear it, but that's because I made a mistake and the volume should be set to 0.1 and not 0.01. Otherwise, you can basically not hear it. So if I do it, if I set it up back to 0.1, and now it should be able to hear it. And now we're ready to work on the game over scene. And for the game over scene, it's just a game object that is going to be a rectangle that will take the whole width and height of our canvas. And it's going to be of a black color. And we're going to have some text. And it's going to, by the way, since we, I think we did this. Yeah, since the background, the page itself is black, you wouldn't need to add this game object. If you set the background property in the KAPLAY context. But if you didn't, you would need to create a rectangular game object to act as your background. So this first line, you can skip it if you use the background property in the KAPLAY context, where you define the KAPLAY context. Now here I'm having some text with game over using the font config, and make sure to import it, etc. And then this is nothing new. Nothing new. And then we wait 2 seconds before going to the main menu so that the player can play again and they can see their top score, of course. And that's it. That's the game. And now if we try to play it, I think we did it. So the game is fully functional now. The only thing left, and another feature I wanted to add, is the ability to pause the game at any moment. This isn't really necessary for this game, but I wanted to teach you this because it's not something you would come across very easily. And in KAPLAY, to make something pause, let's go to main.ts and use the onKey press KAPLAY function and pass to it a function with a param key. And then this will give you the key being pressed. And if the key being pressed is P, that I decided that way, I'm going to get the tree root in KAPLAY. You can do this by doing k.getTreeRoot and take the paused property and set it to the reverse of it. That will allow you to, if the tree root was paused, it's going to unpause it, and if it wasn't paused, it's going to pause it. And now we're going to have another if statement within, and if the get tree root is paused, what we're going to do is we're going to set it in our game manager here so that we can keep track of when things are paused, etc. Now, the reason we need to set the isGamePaused property of our game manager game object is because this is what is used outside in our game for the ducks, the dog, etc. when it comes to their movement, etc. So that means that if this is set to true, it will stop the I think the movement for those game objects. It will stop certain logic from taking place. Now there's a bit of code that is a hack. So we need to TS ignore this because there's this global variable called audio CTX or audio context. And I really don't know from where this comes from, how to type it, but it is something that is globally available in your browser and allows us to suspend our audio context. The reason we need to do this is that for now, if you were to not have this code, what would happen is that the sound of the game would continue to play despite the game being paused. And of course, we don't want that. So that's why we use it here. But since I really don't know how to type it and I haven't found any info on this, I will just ignore whatever TypeScript wants here. And by placing a comment right on top called @ts-ignore. Now, to make things more complete, let's display a game object at the top left corner that says the paused, so that the player knows that the game is paused and hasn't just frozen. To do this, let's create a game object with a paused text using our font config with the position 5.5 and a Z layer being 3. And let's give it a tag of paused dash text, because we're gonna write the logic to remove that game object when the game is no longer paused. So here we're gonna have an else statement which I'm gonna remove in an instant and show you how to use just a return statement instead of having an if else. But just for the sake of explaining, here I'm going to set the isGamePaused to false. I'm going to again ignore the audio context here to resume it using the resume method. I'm going to get the paused text using the get function, KAPLAY function, and then I'm going to destroy it. So now this should work, but now I'm going to show you that you can just achieve the same thing by just having an early return statement in the if statement and then remove the else. So now things should work, and I think it's time to test it out. So let's open up our game, and when I click start and I click P, it is paused, and now I can pause and unpause, etc. And that's basically the game. Everything has been implemented and you have a fully working Duck Hunt clone. And actually there is one thing missing. Yeah, just one thing to remember. In our duck.ts file, I remember commenting out the display shot, playing the shot sound in the shot state. This was not necessary because we played it elsewhere, so you can remove it. And now has come the time to show you how to deploy this. So open up your terminal and run the command npm run build. Once you do this, it's going to create a dist folder. And one thing I forgot to, and then before doing that, to test that it works, do npm run preview and go to the local host, and then you can see if your game is working or not. Now, before doing that, create a vite-config.ts file. And this is just to make sure that it is going to work on websites like itch.io, etc. Import the define config from Vite, which is the build tool we've been using, and then export default a define config and call the define config thing and set the base as a /. This is to make sure that the assets are going to reload in the correct place, etc. So now if you run npm run build and then npm run preview and then open up the game, everything should work. So what you need to do to publish this game is you take your dist folder, you zip it as a zip file, and then you publish it, you upload it to websites like itch.io, etc. So that's the tutorial. That's it. I hope you learned a lot. And one last thing, don't forget in KAPLAY.ctx to deactivate the debug mode by setting the debug property to being false. And now you can run npm run build and npm run preview to test it out, and then you can take your dist folder, zip it, and then upload it on a website like itch.io. So I hope this tutorial was useful to you. I hope you learned a lot. And if you want more tutorials like that, feel free to subscribe to my channel and check out my other content. So thanks for watching, and I'm hoping to see you in another video. Bye.